Here's integrated 3. This is your packet that I gave you, and it is problem 16. And I chose it because it is going to be a downward facing parabola, and also because it's got a coefficient other than 1 on the x squared. So I already showed in a different video how to complete the square in a pretty simple way. So we'll try to do that again here. I'm going to start out by adding 21 to both sides. So I get y plus 21 equals negative 2x squared plus 12x. Okay, and then that went away. Okay, and now I'm ready to get rid of this negative 2 coefficient on here, so I'm going to just factor it out. This would be minus 6x. And I'm going to leave some room for the what I call the magic number to go in there. I think I'm going to do autofocus on here. Hopefully that helped. And then over here I just have my y plus 21. It's just waiting for me to finish my work here. So I'm thinking this is where we complete the square. So we're looking for a number that's going to make this little quadratic inside the parentheses a perfect square trinomial. And the way we introduced this to you is we had algebra tiles. I'm not really looking at that negative 2. That's just going to be my stretch factor later. I'm just looking at what's inside here. So I have an x squared tile, and I have I have 6, negative x tiles. So I split them in half. So there's 3 here and there's 3 here. And then I'm trying to find this number that's going to make this into a perfect square. Like how many ones tiles would it take? And so I can go ahead and count them if I want. 1, 2, 3, 4, 5, 6, 7. It would take 9. So what I'm going to do is add a 9 right here. Okay, and another way to think of that, I call it the magic number. Another way to think of that is to just take the coefficient of x, which in this case is negative 6, divide it by 2, because remember we had to split it into like half here and half here, and then square that. Right, we squared half of the coefficient of x, which actually is b. If you're going like ax squared plus bx plus c, it's b. It's half of b and squared, and we add that to both sides. So to add a 9 in here, I have to add something to the left-hand side. I actually added a 9 inside the parentheses, but really it's negative 2 times 9. So what I really added to the right-hand side of the equal sign is actually equivalent with negative 18. So I'm going to add negative 18 also over here. Okay, so just subtract those. And then I'm going to rewrite this as a perfect square trinomial. I know that 9 is what it took to complete the square, and I know that now I can just say this is x minus 3 and x minus 3. So it's x minus 3 squared. It's a perfect square trinomial. So I'm just going to write it in, I just rewrote it in its factored form and then bring the 3 back over. So there, now I have that, and now it's in graphing form. So graphing form, remember, it's like y equals a times x minus h squared plus k. Right, graphing form. But isn't your book, or isn't your packet calling it vertex form? Standard form, vertex form. So it's also vertex. We'll say it's vertex or graphing form, okay? So that's my stretch factor. And then this thing here and this one, that's h and k. So h, see there's already a minus sign there, so h is 3 and k is negative 3. So my vertex is at h comma k, so it's going to be 3, negative 3. That's my vertex. I grabbed it right out of here. Okay, and then I'm just going to go ahead and, well, you know what? I was going to make a graph of it. I'm going to make a sketch, but then I'll show you the real graph of it, because if you don't use graph paper, you're going to have trouble. Basically, I would make, I would find 3 comma negative 3. I know it faces downward, and I know it has an intercept way down here, because the original was, it shows that my y-intercept is at negative 21. So I know there's an intercept way down here. I'm just going to kind of fake it with my intercept. I'm just going to pretend that that's negative 21. And so there's like kind of a sketch of a graph for you, but I'll show you how to do it on your packet. So on your packet, and here's all my work that I did again, if you're interested in that. On the packet, I just, let's do this. I found 3 comma negative 3, and then I know that the very first, it doesn't really have a slope of negative 2, but I know that the very first points to the right and left of the vertex are going to go down 2 over 1. So I put some points there, and then I tried plugging some stuff in. I tried plugging 5 in, and I got negative 11, which is off the edge of my graph. And then I tried plugging 2 in, and you can see my work here. I plugged the 2 in, and it ended up giving me a negative 5. So I mean, it's not that great, but at least that's something to show. This graph should look kind of skinny because of the stretch factor being the negative 2. Okay, so that's all I got.